Hello everyone, welcome to my YouTube channel. Today we'll be discussing about one of the pressing and most requested system design breakdown of Kafka. How Kafka is used, why it is getting used by most big techs, and out of my 17 subscribers, 15 of them has requested and heavily pinged me to have a breakdown of Kafka and why it is used. And if you are wondering why those remaining two subscribers did not ask for this breakdown, because those two subscribers are my mom and dad. Okay, with this note, we will jump ahead with Kafka. So when we see what is Kafka, so you might be hearing this particular terminology everywhere in the system design. Why Kafka? If you see the Kafka symbol, which looks very weird, which was generated by ChatGPT, you will be like, what is this? Right? And some of the anime fans will be like, is it Hibino Kafka? No, it's not. So the Kafka is generally, it is called Apache Kafka, and it is used in distributed systems for asynchronous communication between different microservices. So let's see what is the official definition of Apache Kafka. So just for the definition sake, if we see, right, the definition says it is an open source, distributed, durable, very scalable, fault tolerant pub sub message system with rich integration and stream processing capabilities. Yeah. So if you write this definition in your college or school days, you would be getting all the marks in the world. But this definition doesn't mean shit if you don't understand what are these words and how this definition makes sense in the real world. You would be like this AI generated boy who is massaging his head and hairs. Like he's like, what is the meaning of this Kafka? What is it? Where it is used? So in simple language, it is like a near real time system where someone can send some data and it will store that data temporarily and it will let processors process that data. And Kafka is infamously known for high speed data pipeline, and it becomes the central nervous system of all the apps connecting to Kafka. And there are some applications, if you see real-time data streaming, and the app can send data, the Kafka can send data, it can process, the processors which are connected to Kafka can process the data, and there are lots of applications because of which out of 500 Fortune 500 companies, 350 companies are using Kafka. So let's try to break down this particular definition. What does it mean to be open source? When we say open source, it is open to everyone. People can contribute, people can use it freely without paying anything. This particular Apache Kafka, right? So that's why we call it, it's a open source. Let's try to break down what is distributed means in the Kafka world. Let's jump ahead and let's see popularity of Kafka among big techs. So if you see, the Kafka helps big tech to scale their applications at insane scale. So for example, if you see the LinkedIn, it processes the data at 197 GBs per second, which is like 10,000 plus brokers. I know you don't know what the broker is. It's not a house broker who lets you find a house in Bangalore. And there are like clusters, which is essentially called a cluster of brokers, multiple brokers. And here if we see, LinkedIn uses Kafka at this particular scale, and there's one more big tech, Uber, again 89 Gbps, 138 million messages per second. So Uber can process this many million messages per second. There are hundreds of nodes they are using currently. Then there is New Relic, again it is in the Gbps scale, again millions of data points per second. Slack also processes the data with 6.5 Gbps, millions of messages again. And then again, Criteo, Netflix, all these companies uses Kafka to scale their application at insane level so that their reach at global level is maintained and they can process millions of data or the transactions. This is the popularity of Kafka among big techs. Then if we move to the Kafka, so why do you think the Kafka is so famous, right? So there are multiple applications and there are lots of problems Kafka solves that traditional approaches won't. So for example, the main problem that Kafka solves, so before Kafka, what used to happen is if there is a producer application and it needs to talk to search, social graph, data warehouse or other applications, it has to individually establish a connection between all these downstream applications. Similar to other application, let's say it's a logging service. And again, it needs to establish the connection between all these downstream applications. And there are like the database tables, multiple databases, many tables, and again there is lots of to and fro between all the downstreams. And one big pain point here is all integrations are owned by a single pipeline team. So when I say a single pipeline team, so one team needs to take responsibility of this whole pipeline where each and every app is connected to n downstreams. So if we see essentially here it is O of n square, right? And if we let's introduce Kafka into this particular messy system and how the Kafka simplifies it. So Kafka itself is a distributed pipeline. It helps the producers to produce the message independently without knowing who the consumers are. So producers can produce their messages to the Kafka. Kafka is a streaming engine. It processes those messages, it keeps those messages, and this will be particularly owned by one single pipeline team, right? Then again, there will be multiple consumers. We can say all these downstreams as consumers, and they will be connected to Kafka. They will be subscribed to Kafka via the topics. So consumers are independent of producers and producers are independent of consumers because there's one centralized system, that is Kafka. So producers produces as many messages as possible and consumers can consume based on their own time, based on what kind of data they want, and based on the topic they want to subscribe. So this is how Kafka solves this messy, huge chunk of problem in a simple manner where the scalability is not just a dream which can be achieved. That is why if we see the big techs use this Kafka at this scale so that they can process millions of messages per second. So whenever it's a system design problem, right, we need to think in terms of data structure. What kind of data structure does Kafka uses? What is the internal working of Kafka? So which is very important to know for a senior level developer. So if we go down, then we can see the main data structure, the culprit behind the miracle of Kafka. So if we see the log data structure, this particular log data structure is a append only data structure where you keep on adding elements one after the other, and then you will have a monotonically increasing offset and it will be read sequentially from left to right. It is something similar to array, but here there are no individual updates or deletes. So you just append the new data. So let's say the new record is coming at 7th offset and you just append it to the log data structure. So the new record will be added at the end. So let's say 8th comes and 8th will be added after 7th. So that is how the log data structure work, and because it is just append only, Kafka is insanely fast because of the property of log data structure. We just append the incoming data to the log data structure and we maintain a monotonically increasing offset. And how these things help Kafka to work behind the scenes and how the producers work, consumer work, I will let you know in this Kafka series. So let's jump ahead and see why Kafka is so important in the real world. So Kafka handles massive data streams, as we see millions of records or millions of transactions per second. It helps in scalability and reliability, where we can expect a eventual consistency, and it lets the big techs scale their applications so that they can reach to a much bigger audience and they can grow their business, like how the big tech giants and the fortune most of the fortune 500 companies are doing. Then again, the one main important thing is decoupled systems. So it decouples the producers and consumers. Producers don't have to know which consumer is consuming their data. So it is decoupled because of Kafka. Otherwise, the producer have to keep a track of which particular service they have been connected to and which particular downstream is getting served with their data. So here, because of the Kafka removes this tight coupling and makes producer and consumers decoupled. So next, if we move to the next particular point, where it will provide a near real-time processing, where the data will be processed almost in real time and eventual consistency will be maintained. So now if we move to the key components of Kafka, which is a producer which produces the message into a topic, Kafka topic, and a consumer which will read, or basically the consumer will subscribe to this topic and read from that topic. These are the main important Kafka components. As I have created this video as the stepping stone into the system design concept and to understand the depth of Kafka. So we will move to these Kafka components in the upcoming videos. Till then, happy coding. Watch this channel, subscribe to uncover complex topics and understand complex stuff in a easier understandable manner. Thank you so much, guys.